All right, that's Mr. Rops.
This is Mr. Song.
All right, so today we're going to do a review of right triangles. And whenever I think of right triangles, there's two things that pop in my head right off the bat. The first thing is the Pythagorean theorem, which I don't know how to spell, so I'll just say what the theorem is. It is a squared plus b squared is equal to c squared. And in doing the Pythagorean theorem, what is special about c is the key to the Pythagorean theorem. What's special about c, Mr. Song?
C is the hypotenuse of the right triangle.
Right, and so it's got to be the longest side. A and B could be either the two legs of the triangle, but C's got to be the hypotenuse. All right, so that's one thing I think about when I think about right triangles. And the other thing I think about is this lovely word called SOHCAHTOA. SOHCAHTOA. What is SOHCAHTOA all about?
Trig ratios.
It is. S stands for sine, O is opposite, and hypotenuse. So if I'm looking at this angle theta, opposite is y, hypotenuse is x. Always you have to pick the angle first to know which opposite is. If I was looking at 72, then this 21 is the opposite. Cosine is adjacent over hypotenuse. And then tangent finally is the opposite over adjacent. Okay, so let's actually do this question here, Mr. Song. We have this triangle here. Let us find all the missing values. I know an easy one. I could find theta. How do I find theta?
Well, the sum of the interior angles should be 180, and I know one angle is 90 and the other is 72. So I can do 180 minus 90 minus 72.
Which I believe is going to be 18. All right, so theta is 18. That's the first thing I can do. Now, would you like to try and find x or y first?
Let's do x.
Okay, so I'm going to choose 72, since this is the angle that's given to us. If I want 72, I'm dealing with x and 21. 21 is the opposite side of 72, and this is the hypotenuse. So I have opposite and hypotenuse. Which trig function is that going to be?
Sine function.
Right, so the sine of 72 degrees is equal to the opposite over the hypotenuse. And so to solve this, I'm going to cross multiply. So I get x sine of 72 is equal to 21. I'm going to divide by the sine of 72 because that is just some ratio. And when I do that, those cancel, and x will be the value. X will be 21 over the sine of 72. We can use our calculator to calculate this. So I'm going to go to my calculator and go to mode first, and I have to make sure that my mode is in degrees. Okay, change it to degrees. And then I can just type in exactly as it's written. I'm going to put it into a fraction. Here's a quick little fraction tip. Fraction, I want 21.
21.
Oh, 21. And I want this to be sine of 72. And so then my x value is 22.1 centimeters. And that's to three significant figures. All right, so there's x. I know this is 22.1. How could I find my y value? I can think of several ways to do it. How would you do it, Mr. Song?
I would use a tangent function.
All right.
Yeah.
You would use tangent. And so if I'm going to do tangent, let's clean this off a little bit. If I'm going to use a tangent to get y, I know I'll change it to purple of 72. Again, 21 is opposite. Y is adjacent, hence tangent. So the tangent of 72 is equal to the opposite over adjacent, which is the 21 over y. If I cross multiply again, I get y tan 72 is 21. And so y is equal to 21 over the tangent of 72, similar to what we just did. Throw this in our calculator. Let's just go up here and see if we can fix this. Tangent to a tangent.
Good try, good try.
Good try. divided by tangent of 72, and I get 6.82. So 6.82 is y. So tangent would work. So another way I could have done it, if I know this is 22.1, is that what we had said?
Yes.
22.1, I could have also used Pythagorean theorem for this. I could have said, with my Pythagorean theorem, I could have said that y squared plus 21 squared is equal to 22.1 squared. And if I calculate y, I would end up with 6.82. I could have also used this angle here, 18, and done y over 22.1. So there's lots of different, which would be opposite over hypotenuse, which is sine. So there's lots of different ways to do it once you have some of your measurements. Okay, here's one I would like you to try on your own. When you're looking for x, y, and theta, when you're done, you should get these values. Make sure you show your work. I'll check it when you are in class.